Hi, welcome to my crypto notification bot tutorial. In this guide, I'm going to show you how to build a simple app that watches the blockchain for an on-chain event of your choosing and sends you a message on Telegram when that event happens. That could be a deposit into some DeFi app, a trade on an NFT marketplace, or whatever else type of event you might want to look out for. Here's actually an example of a DAI token transfer notification. I'm going to teach you how to get raw blockchain event data from Alchemy. I'll show you how to process that data into a human-readable format, and then we'll write the code for your Telegram bot on Replit. Let's get started. Before we begin, I'm going to need you to sign up for an Alchemy account. Like I mentioned before, we're going to use Alchemy to get raw blockchain data. Don't go straight to the site. Please use the referral link that is in the video description. This referral link won't make me any money. It will just help me track how many people actually followed this tutorial. Video views are cool, but I'm much more interested in how many of you actually build something because of these videos. Okay, so use the referral link, sign up for an account, and then we're going to jump into some blockchain data fundamentals. Our Telegram bot will process raw blockchain data to figure out when an on-chain event has happened. Obviously, to build something like that, we need to get a basic understanding of how to interpret blockchain data. We will specifically be studying EVM type data. EVM is the decentralized operating system used by Ethereum, Arbitrum, Polygon, Binance Smart Chain, and a lot of other popular chains and L2s. So you'll be able to apply what you learn here to many different places. There are different levels of depth that we can go into when working on blockchain data. We're going to start our exploration at the transaction level. Now, transactions broadly fall into a few categories: sending another user ETH or whatever the native token of that chain is, creating a smart contract, destroying a smart contract, and most important for our work today, calling a function on a smart contract. Now, smart contract functions are where all the magic happens. If I want to send somebody an ERC20 token or an NFT, I will call the transfer function on that token smart contract. If I want to make a swap on a decentralized exchange, I'm going to call the swap function on that DEX's router contract. If I want to deposit some tokens into a yield farm, I will call the deposit function on that smart contract. Now, when you're using a crypto protocol's website, you don't directly see that a function is being called on some contract somewhere when you're making a transaction, but trust me, this is how it all works in the background. Now, depending on how the contract was written, these function calls can emit what is called an event when they're executed. So, for example, when calling the transfer function of a token smart contract, a transfer event is usually emitted, and these events are stored on-chain, on the blockchain, as what are called logs. Okay, let's take a step back to remember why this is important. In this guide, we're going to pick an event log this is information that is stored on-chain. We're going to pick a log that we're interested in tracking that's tied to, an event that we're interested in. We're going to use Alchemy to watch the blockchain for when a log of that event pops up. So the next time it happens, we're going to see it. And we're going to write code that will process that raw log data into a clean Telegram message. So let's look at some examples of how to interpret logs. The logic we're going to learn here, doing this manually, will map directly to writing the code for our Telegram bot. Let's say we want to make a notification that tells us when a DAI token has been transferred, how much was transferred, and between which wallets. And we want to use the logs that get stored on the blockchain to extract that information. We always start by looking at the project's documentation. Most projects link to their documentation on their website. Looking at the DAI documentation, I can see somewhere about here that this token follows the ERC20 standard, like most tokens, and I can find a more detailed breakdown of that, of that standard's functions and events here on this page. So I'm going to open that up. And as we can see, scrolling through, there are two types of transfer functions, and both of them emit a transfer event. Scrolling down further to check out the event information, we can see that this event contains these parameters: the sender address, the receiver address, and the amount transferred. The first two are indexed. We're going to see why that's important when we look at the raw transfer log in a minute, but just remember for now that they're indexed. Okay, so I have a type of action I wanted to watch for, a transfer. I know the event that's going to be recorded on the blockchain when that action happens. Now I'm going to take a look at the logs and figure out how to convert that raw data into the kind of information that we want to see. So, the documentation usually also includes some information on the address where the contract is deployed. So I can search that address on Etherscan. I've already got that open here, save us a little bit of time. Now, looking at these transactions, they all helpfully state what method was used, and I can see right here that this is a transfer. This is exactly the type of thing that I'm looking for. So I'm going to open up that page. At first glance, there's a lot of information here. We're just going to focus on the key stuff. Now, Etherscan does a fairly okay job of translating things into a human readable format. It shows us here how much DAI was transferred, from which address to what address. And if we open the details tab, we can see that the transfer function on the DAI smart contract was indeed called in this transaction. Okay, so now we're going to open the logs and look at the raw data, the untranslated version of what happened here. So this might look a bit scary at first, right? There are so many weird byte arrays. There are words too, but when we get data from Alchemy, we're not going to see these words. We're just going to see the raw byte arrays in an ocean of other byte arrays that are related to other logs. Now, let me go on a little tangent here. Not all logs on Etherscan will show this helpful label. Sometimes, like in the case I've got open here, you'll open up the logs and there won't be any words on some of them, like this one and this one right there. And that can be pretty confusing. I mean, what does this mean? What information is it trying to share? But don't worry, there are tools to help with this. I'm going to open up OpenChain. This is a tool that was started by Sam Cizon from Paradigm, and it's really helpful for decoding this particular type of madness. If I open up the signature database, I can search signatures. Taking a look, I'm going to copy the signature of this event. Now, this is important to remember. The signature of the event is always the first topic, topic 0. So I can copy and paste that into Sam's tool. And right away, it tells us that this is a transfer event and that it has 3 parameters, 2 that are addresses and 1 that's some number. Now, this is great because sometimes, the documentation is trash and you ask the protocol team questions, they don't respond to your questions. So you don't always go in knowing what the names of these events are and how they're structured, what information they're giving. So in those cases, you just have to roll up your sleeves, find the type of transaction you're interested in on the contract's Etherscan page, or maybe even make a transaction yourself to then see, that transaction on Etherscan, and then you would decode the logs this way. So in this previous example that I brought up, I have no idea what this is, but I can copy paste the signature, topic 0, into here, and that would tell me that, okay, well, that's a swap order ID. It has something to do with a swap, and I guess this is the ID of that swap. And so I can move from there in figuring out how to, detect the type of information I want to detect. Okay, so I'm gonna pull back from my tangent that I took here. How do we translate this kind of data setup that we've got over here? So the parameters that have been indexed, the sender address and the receiver address, go into the topics. You can see that the first one is the sender, second one is the receiver. We saw that in the documentation. We can confirm that by looking at, the translated Etherscan page. This is the sender and receiver, and the parameters that have not been indexed go into the data field. So in this case, the amount is not indexed; it goes into the data field. It won't show up like this, unfortunately. It will show up when we get it raw as hexadecimal, and then we'll have to convert it into a decimal number. Another funny thing, this number looks really big. If you check out the ERC20 standard, you'll find that usually, these amounts that you get are multiplied by 10 to the power 18. There's some technical reasons for that, but the actual amount is this divided by 10 to the power 18. And that's like a pattern that you'll see a lot. Okay. Now, if we get a log, just this stuff without any words from the blockchain, from Alchemy, we will be able to tell that this is a transfer and that this amount was sent from this address to this address just by looking at the byte arrays with no other context. So let's take another step back and actually remember why we're here. We wanted to know when a DAI token was transferred and the details of that transfer. And to do that, we would watch the blockchain for logs with this signature, and we would figure out who sent how much to who using the topics in the data field. Soon, I'm going to show you how to do that with Alchemy, and we'll write code to automatically interpret data that looks just like the data over here. So let's look at one more example real quick, just to cement that knowledge. What if you wanted to watch for a different event, say a swap on Uniswap? I want to be alerted of, what token got swapped by who and what amount and what price, all of that sort of information. I go through the same process. First, I'm going to check out the documentation. I'm specifically interested in swaps, so I'm going to check out this bit of the documentation, and I'm seeing here that, there are some swap functions for if it's a single swap called exact input single and exact output single. I can see that the swap router is used, the swap router contract is used to carry out these function calls. And I'm specifically interested in, what's the event going to look like? I can search events, check that out. And I see that there's an event for initializing a pool, minting an LP token. And this is the one I'm interested in, a swap event that contains parameters about who's the person making the swap and what was the amount of the token that was put in and the amount of the token that came out. Uniswap documentation is great. It has all of that information in there. So, okay, I understand what's going on. I know that I want to look at the swap router, and I know the function and I know the event. So I'm going to go to the deployment addresses, part of the documentation, find the address for the swap router, and I'm going to open that up on Etherscan. Already got it open here. I want to look at a past transaction, so I'm gonna click there and look at the past ones, and we already see some methods that call back to what we saw in the documentation, exact input and exact output. Let me take a look at this transaction. Familiar page, familiar function call, and I'll look at the logs to find the log that I was looking for, the log of the swap event. Now, based on what we learned before, I know how to interpret this. I know that this is a signature that will tell me that it's a swap type event. I know that the sender and the recipient, in terms of the address that was making the swap and the address that would receive the result of that swap, those are indexed, so they're going to be topic 1 and topic 2. They're in order. And I know that the rest of these parameters are not indexed, so they're going to be in the data field. Etherscan has nicely decoded it for me here, but I'm going to get it normally as this hex format. But if I convert it, I'll see that the first bit of that hex data will give me the amount of one token that was put in, the amount of another token that came out, some information about the price, some information about the liquidity in the pool, and about the tick. So, this is another example of how you can manually read raw blockchain data to get the information that you want. Hopefully that helped to, just another example to help kind of cement that process. And yeah, let's move on to writing code to automate this process now. Log into the Alchemy account that you made in the first part of the video. Just a reminder to please use the referral link that's in the video description when you sign up for Alchemy. Now, once you're in your dashboard, I want you to click through to the notify section right there. The product we're going to use today is called the GraphQL webhook. That might sound intimidating if you haven't heard those words before, but don't worry, it's a really simple concept. This webhook will accept some custom filters that we give it, and then it will watch the blockchain for new event log data that might match our criteria. And then as soon as a log that meets our criteria hits the blockchain, it will send that data to us as an HTTP request. Now, you don't really need to know what I mean by HTTP request, just know that that's a standard format that applications use to communicate on the internet. So to start, let's make a webhook for a DAI token transfer. To do that, we want to filter for two things. We will want to filter for the DAI contract address and the signature of the transfer event specifically. So I'm going to create webhook by clicking that button here. This is for Ethereum mainnet. That's exactly what I want. There's a whole structure here that kind of shows this is all the type of information that will get sent to us. But you don't need to worry about that just yet. What we want to worry about is the filter. So we're going to put the DAI contract in in the addresses field. The little comment shows that yes, we add smart contracts to this list. So we're going to copy paste the contract address. Got to put that right there in quotes. So that will filter for this contract address. And then we're going to filter for the topic 0, which you might remember is the topic that holds the event signature. So this topic 0 right here, if you remember from the last bit of the lesson, this is a signature that tells everyone that this is a transfer event. So that's what we filter for there. And by using these filters, we're only going to get events that meet our criteria. So with 1-2 simple edits, we've now got a webhook here that will send us the event data, the log data for new DAI token transfers. And we want to test this to make sure that it works. Very soon, we're going to be writing a simple server that will be able to receive and process data from this webhook. But for now, we're going to do a bit of a hack, and we're going to use a website called webhook.site that's specifically made for testing webhooks like this one. We can use webhook.site to receive a message from Alchemy without having to do a lot of setup. What we're basically going to do is we're going to copy this address that we get given here, and we're going to give this address to Alchemy in this field as please send information to this address. Now, for the purposes of this test, we can actually tell the webhook to send us data about transactions in a particular block. In actual practice, when we make the final app, we'll want the webhook to listen to all new blocks and send us all new information, but right now, just to see how it works, we'll just query one block. So I'm going to go to Etherscan. I'm going to pick, one transaction that has a DAI transfer. And I'm going to copy the hash of the block where this transaction occurred. So I can get that right here. This is the hash of the block, and I'm going to give it to our webhook to say, well, in this case, just send us event logs that meet our criteria that happen specifically in this block. Obviously, from the term blockchain, I'm sure you already know that transactions on a blockchain all get grouped into blocks and added onto the blockchain in groups called blocks. All right, so now we've got our webhook all set up. We're going to test it right here, send a request, and we'll be able to take a look at it. All right, so it's already come through, and here we can see the result. It tells us that in the block we provided, these were all of the event logs that matched our criteria. And, there's other information there about that was the hash of the block that we shared and the timestamp of when it happened. In all of these logs that we get, we can see that the first topic 0, is the signature of the transfer event, and the second and third are the sender and the receiver address. They're padded with extra zeros because the data has to be a specific length, but trust me, these are the same results you'd see in Etherscan. And same as before, the data field is the amount of token that was transferred in hexadecimal format. But actually scratch what I said earlier, you don't have to trust me. You can compare what we're getting here to see with Etherscan to see that it's exactly the same. So this is the transaction that I used before to pick the block that we asked Alchemy for, so we can compare what we're seeing here to what we're seeing here. I think it will be this one. So we can compare and we can see that, in this block, the sender was DD72. Here, the sender is DD72 and the receiver was 71C. Here, the receiver was 71C. We can also compare and see that it's the same amount. So yeah, really what you're getting is exactly the type of data that we were seeing and manually interpreting on Etherscan before. But now, you can get it in an automated way and do stuff with it in an automated way. And that's what makes this really interesting. Alchemy will send us a data structure like this at every new block. So if the block doesn't contain any logs that meet our criteria, then this logs field will just be empty. And we can filter by more than just the first topic. We can also include other topics in our filter. So if I only want to get logs where the topic 1 is this, so in this case that means that the sender of the transfer is this person, I can add that to the GraphQL statement. So I can copy that, can come here, can add it as another element in the filter, and I can run another test. And you can see that we've gotten a new result right here. In the new result, we see that only the log where topic 0 was the transfer signature and topic 2 was the sender address that we gave to Alchemy. You can see that's the exact same one. Only the log that matched this criteria was sent. Other ones that didn't match this criteria weren't sent. Hopefully you can see how you could adapt this to other events. For example, sending yourself logs of Uniswap events where a specific token was swapped by adding all of the right topics here. Apart from kind of this raw log information, we also get other information about the transaction where the log happened, like the gas price and the contract address that was interacted with and other such things. But we can really get most of the information that we want by just looking at the logs in the way that we've been doing this whole time. So now we know how to set up the Alchemy custom webhook to send us data on a particular type of log that's emitted from a particular contract. And moving on, we're going to ditch this webhook.site page and write up our own server that can receive data from the webhook and process it into a Telegram message. Now, you can edit the criteria that we looked at here to filter for another type of event, but I'm going to keep running with this die transfer example for now. Now we finally arrived at the fun bit, which is actually building our Telegram app. The language we'll be using is JavaScript, more specifically Typescript, which is like a super set of JavaScript with types. We're going to be using Express, which is a popular Node.js framework, which makes it really easy to build web applications and APIs. Express basically has all the functionality we'll need to receive HTTP requests from Alchemy and respond to those requests. So we're going to write and host our new app on Replit. Replit is an amazing platform that lets you write code in your browser and run code in your browser. So the first thing I'm going to need you to do is sign up for Replit, which is, same process as anywhere else. And once you're done, please go ahead and log in. I'm going to log in myself just now. And that will bring you to your homepage. That will look like this, and all of your projects will be in the My Repos folder. So what I'm going to need you to do now is click on the link in the description. That will take you to the repo for the crypto notifications project. So I've already got this open in this tab. The page will look like this, and we're going to go ahead and fork the project to basically make our own copy that we can edit and we can save and do all of that good stuff with. Great. So now it's booting up, and we're gonna have our own version of the project to look at. We can see how everything is laid out in the file manager. There's only one file in here that's really important. That's the index.ts Typescript file in the source folder. There are lots of other files here that are really just kind of requirements for any Node.js type project. You don't need to know too much in depth how they work. So we can go through this line by line and, see how it all works. The first statements that we have here are importing the Express and the Telegram API packages that we're going to need. Then we've got our main function that actually holds all of our logic. In there, we create an Express app and we set it up to process new request data that we get in a standard format that's called JSON. We've also got a variable here for the port that our server is going to use for communication. Just kind of think of that as a very simple ID of the port that our server is going to listen to requests on. Then we create this interface for communicating with our Telegram bot. So the Telegram bot is like a user on Telegram who just happens to be controlled by code. And each Telegram bot has a unique key. We'd give our interface that key, and that key gives you control over the bot. Now, for safety reasons, we don't just copy paste that token out here in the open, because anyone who sees it would be able to have full control over your Telegram bot. So we store it secretly in this environment variable called bot token. I'm going to show you how to set up that environment variable later. And I'm also going to show you how to get the token from the Telegram side to put it in here. All right, after that, we've got another variable which is used to hold the ID of the specific chat thread where we talk to our bot. So, if we open up Telegram, like all of these is a different chat thread. This would be the ID of that specific thread. And finally, this statement here is real simple. It basically means that the bot will wait for you to send it a message that looks like /start. And once it gets that message, it will know that this is the chat thread it should use to talk to you. And it saves the ID of that chat. It will also send you a message to let you know that it's recognized. Hey, I saw you send the message. Everything's set up now. We can get started with messages. Next, we have the most important bit. This is the handler that actually receives and processes the raw data that we get from Alchemy. It has all the logic, in this case, specifically written for the DAI token transfer use case, but you can edit it to fit any other use case of any other event that you might want to look at. So here's what happens. The Alchemy webhook will send a request to the /notify endpoint, a request that looks like the data we saw on webhook.site last time we were testing things out. And then the handler logic will extract the relevant information. So we've got this long line here that basically means that, okay, it will look at the body of this message, and it will extract the information in the event section. Out of that, it will extract the information in the data section. And out of that, it will extract the information in the block section. And finally, it will reach into the block section and pull out the logs, which are the most important bit that we actually want. So that's what this line does. And, if there aren't any DAI transfer logs in that block that Alchemy sent, the log section will just be empty. We'll note that it's empty and move on. But if there are actually logs in here, then we start this process where we'll basically loop through every single log and, execute some different instructions. So for each log, we will save the sender address, which we know is, in the second topic 1, and the receiver address that we know is in the third topic 2. There's some logic here for removing all of those extra zeros at the start of those addresses. Then we've got another statement for taking the amount, which we know is in the data field, and converting it from hexadecimal format to decimal format. We're also going to divide it by 10 to the power 18. We know from the documentation that the value that we get is huge because it's actually been multiplied by 10 to the power 18. Now, using that, we construct a pretty straightforward message, and that message being that, the wallet 1, the sender, sent X amount of DAI to wallet 2, who's the receiver. And now we have this statement, which basically means that, if the chat has been set up with the user, like, they sent /start, and now we know which chat ID to use. If that chat has been set up, then the message is sent to the user on Telegram. And if it hasn't been set up, then we just note the message and we move on. What we're going to do after we send that message is that we will send back to Alchemy this status 200, which basically lets Alchemy know that we received the information. If Alchemy doesn't get this 200 status report, it will keep retrying to send us the message. This bit here basically means that our app will be listening for new messages at the port that we specified, and this statement runs our main function. So that's a wee rundown of how this app works. Next up, we're going to create a new bot on the Telegram side and link it to this server, give the server control by giving the server its key, its bot token. Creating a new bot in Telegram is really simple. You just have to go into the Telegram app. I'm going to open that in this tab right here. And you want to message a bot called the botfather. So the handle is @botfather. That's it right there. And to make a new bot, you just send it the message /new bot. So it's going to ask you for a name. I'm just going to call this bot, crypto notifications Typescript. Call it that. And then you need to give it a username. So I'm going to call it notifications to bot, something generic like that. Oh, that's already taken. So notifications type bot. Great. And then it will give us the API key that we need to take control of this bot. Of course, usually nobody should see your API key. If they see it, then they can take control of your bot. So please keep it to yourself, even though I'm not following good security practice by showing it to you right now. So now I can go back into my REPL and I can, put that value inside of the bot token environment variable. To do that, I'm gonna open up this tool called secrets. That's great for hiding your secrets. And I'm going to create a secret that has the name bot token. I'm going to copy in the value that I received from the bot father, adding that new secret. So now that's saved in there, and I've already, called that secret inside of the app. And this is great because now you could share this with people, other people could see it, but only your instance of this project will have the secret, which is your token. All right, so now we're going to go ahead and bring our project to life. There are a few steps here. First thing I'm going to do even before that is I'm just going to go and make sure that the bot token was saved correctly in there. That can cause some problems if it's not saved right, but yep, seems like that's okay. So now, knowing that that's ready, I can go into my shell, and to start this server that we just wrote, I'm going to use the command npm start. Then I'm going to press enter. So now we wait a moment, and we can see that the server is live now. The app is listening at the port that we specified, so that's ready. Next thing we're going to get ready is the Alchemy webhook. So just as we did before, I'm going to open up my Alchemy dashboard. I'm going to go to the notify page. I'm going to create a new webhook, and I'm going to add the appropriate filters. You just search for the DAI token contract. I'm going to copy that into here. And I'm also going to copy the topic that is related to transfer events. I'm going to copy that right in there. All right, so I've got the filtering set up, and I'm going to give it a URL of where it should send this information to. We can see in this web view tab that the link for our server is this one right here. It's usually your server name.yourusername.repl.co. It kind of always follows that same format with Replit. And I'm going to add on to the end /notify, because we wrote our server in such a way that the notify endpoint is what should be receiving the information. So, yep, all of that looks good. I'm going to go ahead and create this webhook. So now it's created, it's active, it should be sending new information to our server at every block. If I open up the shell, I can start to see that it's actually already starting to receive information. As you remember when I was explaining before, if chat ID has not been set up yet, it just notes the results that it receives. So right now it's just noting those results in the shell console. It's not sending it to anybody. So now we actually wanted to send the messages to us as we specified in that line. So we've got to, send a message to our bot to bring that to life. We know that this is the link to our new bot. The bot father very kindly showed us the way. So we're going to open up that link, and we are going to start this conversation. We get our message that our notification bot has been set up. And now, instead of noting new information in the shell console, it should be sending that information to us. So we're just going to wait a moment, and the notifications should start rolling in, because people are always transferring DAI to each other, so it shouldn't take too long to start to see some real results. Amazing. So we can see that it's starting to work, that just a moment ago this address sent this much DAI to another address, and these are just going to keep on rolling in because people are always doing DAI transfers. If it's a less common event, then you probably wouldn't be hit up with notifications all the time, but it's fantastic. This is a live app that will ping you, and you can edit the project however you'd like in terms of checking for a different event, using different filters in Alchemy, and changing the way this code works to process that event into whatever type of message that you'd like. And it's kind of, the world is your oyster. You can apply this to so many different types of blockchain use cases. Now, one thing to note is that with Replit, this server is not going to be constantly live forever. It's only going to be alive as long as you have this tab open. If you want it to actually stay live even when you close this page, you'll want to use the always on method, but always on is not free. It costs 20 credits a day, and I think with how much credits cost, that's like a few dollars a month or something like that. It's really inexpensive. It's kind of, you don't need to pay just to test it out and to try and just make sure that it actually works. So hopefully, I can understand we've covered so much content in this video up until now, but hopefully you've kind of internalized those steps of learning how to interpret event data just manually looking at Etherscan, and then how to write some code that will actually automate the process of interpreting that data, and how to set up an Alchemy webhook that will constantly send you new data to finally have this notification experience that we were looking for. To make sure that I don't run out of my free Alchemy credits, I'm going to go ahead and I could either deactivate, or I could completely just delete this webhook that I've made. Either's fine, but since this is just a test and I'm not actually using the bot day to day, it's perfectly a good strategy to deactivate or delete your webhooks so that you can conserve on your credits. Alright, so you have reached the end of the Telegram notification bot tutorial for on-chain events. Congratulations. And I really mean that. You had to wade through a ton of new information to get here, so you've been really patient and you've done an amazing job. To recap one last time, we've walked through the basics of reading raw blockchain event data, setting up an Alchemy webhook to send us raw event data, and writing a JavaScript app that accepts the data from Alchemy to craft it into a Telegram message. We've covered a lot of ground today, but I hope that for you it's really just a start. I focused a lot of the guide on the use case specifically of a token transfer, specifically a DAI token transfer, but you should definitely try reading the event data for another event on another protocol that you're personally interested in, and making a notification bot for that. If you're stuck on the JavaScript side of things, you don't know how to edit the JavaScript that we wrote in to do something that you want to do, I would recommend just using ChatGPT to help edit the script how you'd like. And if you're stuck when it comes to understanding blockchain data, please drop a comment underneath this video, or come visit us in the Alchemy Discord, and we'll try to answer any questions that you've got. I'll personally do my best to answer any questions that appear in the comments. So yeah, take a deep breath. You've done a great job. Thanks a lot for taking the time to run through this lesson. Let me know on Twitter what you thought, whether this guide needed more explanation, less explanation, what you'd like to learn to make next, any other feedback you have. Gonna try my best to make these as useful as possible for you guys, and I can't wait to see all of the cool stuff that you go on to make. Looking forward to next time. See you then.